Yeah. Okay, the next lesson now. I just zoom in. Exponential equations. Don't make me separate you, please. Okay. Did you write that down? Did you? Did you not learn your lesson?
Oh, no, I got it. It's fine.
Okay. So what we're going to look at in this lesson is problems where the x is in the power. Using the rules we have, we can try and solve for x when x is in the power. So let's do some examples. 64 power x plus 2 equals 4 cubed. So this is what I mean by exponential equation. The thing you want is now in the power. Yes? Do you understand what I mean? The unknown is in the power. So, what we try to do for these problems, if it's possible, we try to simplify the 64 and the 4. So the 4 you can write as 2 squared, like this. And the 64 is 2, 4, 8, 16, 2 power 6 is 64. Okay, is that okay so far? Now we can use rule 3 of the powers. This is equal to 2 power 6x plus 12, and this is equal to 2 power 6. Is it okay? Are you sure? Yeah? Now, when you have 2 power a equals 2 power b, the only way this is possible is if the a and the b are the same. So we must have 6x plus 12 equals 6. That means 6x must equal minus 6, which means x must equal minus 1. It's always good to check these answers. So let's check. 64 power minus 1 plus 2, that equals 64 power 1, which is 64. And then 4 cubed is 4 by 4 by 4, which is 64. So yes, x equals minus 1 is an answer. You don't need to check in the exam. I'm just checking to show you because it's our first example. So the answer here is x equals minus 1. Write this example down.
So 64 squared is equal to 4 cubed.
64 squared?
No, it's not.
Okay.
Yeah.
Why not keep the 4 as it is and just 64?
You could, but it's a good habit to try to reduce the base to a number that's as small as possible. So for good habit reasons. Oh, that's true too, but it doesn't always work nicely like that for these. In the exam, you usually have to reduce it rather than expand it. Can I do another example? Yes. Okay. Okay, let's scroll down. Yep. Next example, we'll make it a little bit harder now. 5 power 6x minus 9 minus cube root 125 power 5x minus 5 equals 0. Yeah. Okay. First, well, I'll let you write it down first. Okay, first thing to do, I should move the cube root to the other side. Okay? There's nothing I can do with the 5, but I suppose at least I can change 125 into 5 cubed. Next, cube root is power 1 over 3. So now we have 3 powers to multiply together. We have 3 times 5x minus 5 times 1 over 3. But what's nice is that the 3 and the 1 over 3, they cancel. So I can cancel that with that. So now I get 6x minus 9 equals 5x minus 5. So, of course, 6x minus 9 must equal 5x minus 5. This means x must equal 4. You can write that one down. That's our second example. Did you write this down? Yeah. You have this? We can do another example? Yeah. Okay. Let's do a harder one now. Example. 9 power x minus 12 times 3 power x plus 27 equals 0. Okay? Anybody have any ideas on what I should do first?
You should move the 27 to the
No.
divided by
Factorize 3.
Huh?
3.
Factorize 3.
Divide by 3?
Change it to all 3 numbers.
No, actually. No. Not make all the numbers become a 3. Huh? Transfer?
Put
Transfer
3
what
x
to
as
where?
an 8.
Transfer what to where? Ah, yes, okay. You're getting close. So you mean a substitution? Yes. There is something we need to do before that, something small to do first. You have the right idea, but there's one little thing to do first before doing that.
Change 9x to 3x.
Yeah.
Change 9x to something, multiply 3x.
No, he was right the first time. Change 9 into 3
X.
squared.
Yeah.
Or 3x. It depends which way you want to write it. 3 squared x minus 12 times 3x plus 27 equals 0. Or you can write that as 3x squared, because these powers multiply, so it doesn't matter which way around you put them. Now, just to make this super clear, you have 3x squared minus 12 times 3x plus 27 equals 0. So this looks like what type of equation? It's a quadratic. So we have two factors here, but instead of x, it's 3x. Numbers that multiply to make 27 and add to make minus 12, well, it has to be a minus and a minus, a 9 and a 3. So you get either 3x minus 9 equals 0, or 3x minus 3 equals 0, which means either 3x equals 9 or 3x equals 3, either 3x equals 3 squared or 3x equals 3, 1. So finally, either x equals 2 or x equals 1. Now, you were saying about replacing it. Some people like to do that. They replace the 3x with like a u or a t or something. And that's fine. But I kind of got into the habit of not doing that, because I feel like it's just as easy just to leave it as 3x and just think of the 3x as the variable. But if you want to replace it, that's fine.
What do you mean by replacing?
Yeah, some people like to replace the 3x with a letter like u. So then this you can write as u squared minus 12u plus 27.
Let 3x equals u. And then you write it, yeah.
It just makes it look a little easier, a little neater. You can do that if you like. I don't really feel like it's necessary though. That's why what I did was I just wrote 3x in red, so I can make it stand out as a variable by itself.
You want one?
Yes, I do. Throw. Oh no, where is it? You can't promise me one and then not have one. Awesome. Thank you. Okay. Can we do another example? Yep.
If you want to.
Minus 8x minus 9 over 5 as the power, and minus 3x power 7 over 6. Okay.
This is very, very
Different. Any ideas on what to do first?
Foot long.
No.
transfer minus 8 to minus 2 cubed.
I think you want to well the very first thing to do is cancel those minuses. Very first thing. Then I'll divide by the tray. How many do you have?
Enough.
Enough. X 7, 6 over x minus 9 over 5. Can you see what I did? I brought the 3 down on the left and the x down on the right. Yeah? Okay. What can I do on the right? What rule can I use?
Minus
The second rule.
second.
7 over 6 minus 9 over 5. So that's 7 over 6 minus 9 over 5. 89 over 30. So there's one line left. Does anyone know the last step here?
You just put
Not
the
log, because we haven't used that yet.
30 over 89 on the 8 over 3
As a what?
as power.
Yeah. So to finish, you put power 30 over 89 on both sides, because that will cancel the power here, and you're left with x equals 8 over 3 power 30 over 89. Although you can simplify that a little bit, but I won't. I think this is good enough. So this one's a bit tricky. I have seen it in the exam a couple of times though, so please write this one down.
Like B and C, their numbers crazy.
Mhm.
Is it you who made the questions?
Yeah, these are all my worksheets I've made.
Oh,
I've got my name on the bottom, see? Where's the copyright Stephen? Yeah. Look at the bottom of the answer page.
Every time I see the number like this, I was.
You're thinking, what son of a... You see, I have nothing better to do with my time than to sit at home thinking of hard questions for my students to do. And as you can see, I had a lot of time. Okay, can I do another example? Something else? Yeah?
Can you go back? Just a second. Yep. Yeah, okay. Thank you.
Right. I have this graph and I have this graph, and I would like to know where they meet. So roughly speaking, this graph will look something like this, and roughly speaking this will be going down, and it'll be I think it'll be something like this. So they'll meet somewhere here. That's not so important. I just know that they'll meet, and I want to know where do they meet. So how can I find where these meet? In other words, what method should I use to solve this?
Log.
No, I haven't done that yet. Not that today. Substitute. Yeah. This equals y and this equals y. So we can say 1 plus 3ex equals 7 minus 2 over ex. So I can say 3ex plus 2 over 3ex minus 6 plus 2 over ex equals 0. Can you see? That's okay so far?
Yeah.
I just took everything to the left. But what to do next? Who can see what to do next? Multiply everything by e power x. So you'd have 3 minus 6 plus 2 over ex equals 0. Well, these cancel, and ex times ex is ex squared. So now you have 3 squared minus 6 plus 2 equals 0. And you realize, oh, I know this type of problem. What type of problem is this? The quadratic. Does it have factors? Let's find out. I don't know if it does actually. What am I doing? I can be lazy. Mode 53. 3 minus 6 and 2. No, it doesn't have factors. So you would have to use the formula here. Ex equals...
Question.
Yes.
Can we not use ln to remove the ax?
No, we cannot. There's no point we could use it yet. Ex equals 6 plus or minus square root b squared minus 4ac. 4 times 3 is 12. 24 all over 6. So you get two answers here for ex. Either ex equals some number here, which I'll get on the calculator, or ex equals some other number. So the first one is 3 plus root 3 over 3. No, something feels wrong. B squared minus 4ac. No, that's right, yeah, okay. Our ex equals, oh, of course, minus here as well. 3 minus root 3 over 3. Now, there's only one thing left to do. Watch carefully, please, the last step. So think about what you're doing at the very end here. You're saying e to what power makes 3 plus root 3 over 3? And e to what power makes 3 minus root 3 over 3? This is literally the definition of logs. You use logs to find the power. So the answer here will be x equals log base e and log base e. Because remember what log means. Log means e to what power makes this number. That's exactly the thing we're looking for.
Yeah, that's what I meant.
I don't think that's what you meant, but if you tell me, I'll believe you.
Use ln to cancel e. So
No, but you were asking me prior to this, as in to get to that point I was at, not in the future. Unless you're asking me questions in the future now. Please restrict questions to the present or the past, not the future. Thanks. Okay, write this one down. This is a common exam question as well. Sometimes in the exam, they want you to leave the answer like this. What word might they use in the question to mean to leave the answer like this? No. What word might they use in the question to mean leave the answer like this? So, word. No. Nice try, but no. Not quite. Still not rational. Wasn't rational the first time you asked.
Don't simplify.
Huh?
Don't simplify.
Give x.
That's 2 words.
Give x.
No, you can only use one word, so you've just used it up when you said give. No?
Leave your answer.
Okay. Exact. So if the word exact is in the question, it means they want the answer left like this. So if you see the word exact, it means like this. So it might say, solve for this exactly. or what is the exact solution or value, yeah. If they don't use the word exact, then they're happy for you to give this as a decimal. So we'll just see what that is. Let me just type this in. Log 3 plus square root 3 over 3. 0.456. Or, if I put in the minus 0.861. Okay, so it's a very it's very common mistake. Listen, it's a very common mistake in the exam for students to think that the word exact means this. 90% of students will read the word exact and think they must give the answer like this. It's not. Exact means in this form, without the decimal. Okay? So don't you make that mistake. Exact is actually a little bit nicer because you can finish a bit sooner in the question. Yeah? Okay. Do you have this written down?
Sadly, it means you can't use a calculator.
Huh?
Exact means.
And it means you can't use the calculator too, yeah. Yeah?
So if they don't mention the word exact, can
If they don't,
can we
if,
just leave it like that?
I think it depends on the question, but usually, yes. But it really depends on what
Right,
is in the
to
question.
safe side.
Yeah, if you're not sure, give both, if there's time. Yeah. But unless they say exact, then decimal is always okay in the exam. I know that for a fact. So, unless it says exact, you're good with decimal. Okay, did you write this down? I can give you the homework now, so... One, A, B, C, D. 2, A, D, U. 5, 6, please. Show some mercy on your poor teacher. 3, A, B, C. 4, A, B, and 6. Okay, please write those down so I can close it. You can start them now for a few minutes, I think. Yeah, just do these for 5 minutes. 5 minutes.
Is there a way to get the x when there is a, let's say enter an ex power with 1 over 2
Ex power
equals,
like this?
yeah, no, equals like ex power,
Ex power
yeah, equals,
like this?
yes, like 1 over 2. Like, is there any way to get
Yeah.
ex?
X is log 1 over 2.
Yes, that's what I thought, but the answer is different.
Or maybe it's a mistake at the back then. Not. I know it might be difficult to accept that I made a mistake, but it's possible. So we can look at it in the tutorial if you like.
Okay.
Yeah? I can close this. You have these?
Yeah.